Water in motion is important to understand if you're building a pond with a stream, a pondless stream, or a pond system that incorporates a negative edge. In this video, I'd like to take a look at the basics of water in motion, why it's important to understand, how you calculate the water in motion, and then how you accommodate that water that is in motion. If you don't already know me, my name is Kev, and the aim of my channel is to help people build and maintain a pond without spending a fortune. If that sounds like something that interests you, you might like to subscribe and visit my website, ozponds.com. Okay, so if we have a pond and a stream, the pump is sending water to the top of the stream and it returns to the pond via gravity. If the pump is turned off or shuts off due to a power outage, all the water inside the stream will return to the pond. If the pond's already full, the pond overflows. So you're thinking, well, that's no big deal, and it probably isn't, especially in a large pond with a small stream. But if you have a lot of water in the stream, it can create a bit of an issue. In this situation, you can lose a significant amount of water when the pump shuts off, and then when it restarts, the water level in the pond can drop significantly. This can be annoying, but it can also cause problems if you're running a skimmer or an intake bay. If water level drops too low, you can starve the pumps of water. In a pondless system, or a system using a negative edge, the reasons for calculating water in motion are essentially in understanding how big your reservoir needs to be. A negative edge is when the pond overflows into a reservoir buried in the ground. A negative edge is a type of skimmer. As the water cascades over the edge of the pond, it creates surface tension, and that pulls debris over the edge and into the top of the reservoir. A negative edge and a reservoir can be useful to drought-proof your pond, as you can store additional water in the reservoir. This can mitigate the need for top-ups of the pond. In a pondless stream, the reservoir needs to be able to collect all the water in motion if the pump shuts off. Because if it didn't collect it all when the pump restarts, there wouldn't be enough water in the reservoir to run the stream and the pump would run dry. In both a negative edge and a pondless system, the reservoir should be able to handle twice the amount of water that's in motion. So that means if the reservoir is full and we start up the pump, half the water will be in motion before returning to the reservoir. If we shut the pump off, the reservoir will return back to full. With that said, there's absolutely no reason why you can't oversize the reservoir, but you should never undersize it. I should also point out that your reservoir volume should be made up of empty space, so the use of a matrix block will maximize the amount of free space in your reservoir. I do have a video on alternatives to aqua blocks, so I'll link that in the description if you're interested. Okay, so that's real quick why water in motion is important. So how do you calculate it? Well, that's easy. We just need to calculate volume, and most of us will remember from maths class that volume equals length times width times depth. I'm in Australia and we use the metric system, so I do all my calculations in meters because I know 1 cubic meters is equal to 1,000 litres. For my American friends, you'll want to use feet, and you know that 1 cubic foot is equal to 7.5 gallons. So when you calculate the water in motion, you need to calculate all the water that is in motion. A pondless stream is easy. It's just the average depth of the stream times its width times its length. Now you've got the volume, and you size the reservoir at least 2 times the volume of the water in motion. The average depth of the stream will vary depending on the size and look you're going for. If it's not a pondless system, that water will end up in the pond, so ideally we want to be able to accommodate that water if the pump shuts off, rather than have the pond overflow, and that water be lost, and the level in the pond drops when the pump restarts. On this pond, I have quite a large and wide stream for the pond size, so I needed to allow the water to fluctuate quite a few inches if the pump shuts off. Therefore, the intake bay is designed so that it can have a fairly deep level of water over the choke point. If you have a store-bought skimmer situation, you might only have a few inches to play with. We can work out how much the water can fluctuate without loss by calculating the surface area of the pond, width times length, and then saying, okay, I can accommodate an extra 10 centimeters, or whatever the measurement may be, before the pond overflows and I lose that water. I hope that's not too confusing. It's only really an issue if you want long, wide streams and a small pond. You just need to be aware of that water fluctuation if the pumps are shut off. If you have a negative edge system, you'll need to incorporate the volume of the stream and the surface water on the pond, because when the pumps are shut off, there's going to be a few inches of water on the pond surface that will cascade back down into the reservoir, and this can be significant on large ponds. I should also mention that you'll need to incorporate the surface water of a bog filter. In small filters it won't matter, but if you have a large bog filter, that surface water that will overflow into the pond will need to be included in your water in motion calculation. Now, all this is only really important for people attempting more ambitious projects. Your average goldfish pond, this really isn't going to be an issue. It was certainly something I was aware of, and I calculated when I constructed the ponds and streams in my front yard. There are ways you can minimize the water in motion. Lower pump flows will mean shallower water through choke points, and therefore the depth of your measurement will decrease. Of course, you'll need to weigh this up with the aesthetic you're trying to achieve. I have other videos on how much water you need for waterfalls and streams, as well as guides on my website. You can also widen your choke points so that the water flowing over them is thinner. This is particularly useful on a negative edge system where the pond is large. The difference between an inch of water over the surface area of an entire large pond can be significant. This will reduce the size of your reservoir needs. Anyway, this was a bit more into it than the average DIY pond builder needs. But I know a lot of you have started smaller and are looking to take on more ambitious projects. So hopefully this was helpful and not too confusing. Basically, you just want to understand how it works, how to calculate it, and make sure that your pond or reservoir can handle the amount of water that is in motion. Or have a battery backup so that your pumps will never shut off. Anyway, I do hope this was helpful. Thanks for watching. See ya.